Today we're going to talk about systems of linear inequalities. A system of linear inequalities is kind of like the system of equations that we solved before. You're going to find a set of points that make both inequalities true. A system of linear inequalities then consists of two variable inequalities in their graphs. It can be more than two linear inequalities, but the ones that we're going to tackle today only have two inequalities in them. So here's our first example. I'm going to tackle each inequality separately. So first I'm going to take a look at y is greater than or equal to 2x minus 3. Just a reminder that if it was just greater than or just less than, I would use a dashed line. Greater than or equal to or less than or equal to, however, uses a solid line. So I'm going to graph that line first. This says to start at -3 and it says to go up to right 1 from there. So we're going to be headed off in this direction. I'm going to extend my line so that it goes all the way across the graph. Make sure that you're doing the same. That's an important part of graphing. And now comes the all-important test point. I'm going to pick some random point that is not on my line so that I can test for a solution. So I'm going to choose the point 1, 2. There's nothing special about that point other than it's not on my line. So again, this is the point 1, 2. Let me take down the thickness of my line for just a second. Okay, so I'm going to plug this in. Remember, 1 is our x value, 2 is our y value. So I'm going to take my inequality and I'm going to plug a 2 in where y is, greater than or equal to 2 times x, which is 1, minus 3. 2 times 1 gives me 2, minus 3 on this side. 2 minus 3 is -1. Is 2 greater than or equal to -1? If this is true, which in fact it is, then I know that that is the side of the line that needs to be shaded. If my test point proved my inequality to be false, I would want to shade on the opposite side of that line. So I'm going to grab some shading and we are going to shade. Let me make this nice and big here so that I can do it all at once. And I'm going to shade everything on this side of the line. Next, we have to tackle the blue inequality. So y is less than or equal to -1x or -x plus 1. That tells me, first of all, that my line should be solid. That's going to be an important point for us. We start at +1 and our slope of -1 says go down 1, right 1. So starting at 1, going down 1, right 1 takes us on a diagonal. I'm going to extend the line so that it goes all the way across my graph in both directions. And now I need to pick a test point to test for solutions. So I'm going to choose, let's pick the point 4, 1. Just some random point. As long as it's not on my line, it's great. I'm going to plug it in for x and y in my inequality. In this inequality, y is 1, x is 4, -4 plus 1 is -3. Is 1 less than or equal to -3? Since this is false, that is definitely not true. That tells me that that is not the side of the line I want to shade. I want to shade the opposite side of that line. So my solutions are all over here. When I have both shadings in, this is where this is where the system actually comes into play. Remember, I want to find all of the points that make both inequalities true. All of the yellow shading makes my first inequality true. All of the blue shading makes my second inequality true. So what I'm going to look for is this portion that makes both inequalities true, or where the two shadings meet. So this part where the two shadings overlap is my solution. I can pick any point in this area, plug it into both inequalities, and both will come out true. So that's kind of the gist of it. I'm going to shade both inequalities, or I'm going to graph both inequalities with shading, and I'm going to look for where the two inequalities overlap. I'm going to use some colored pencils. You're going to use some colored pencils on your assignment so that you can show me where the two overlap, and that's going to be in a different color. So let's do one more. First inequality in red tells me that I need to start at -5 and go up 4 right 1, and my line is going to be solid. So starting at -5, going up 4 right 1, let's get this in the right place, right about there. I'm going to extend it so that it goes all the way across my graph in both directions. Something like that. Now I'm going to pick a test point to help me look for which side I should shade. Oh, that's a tongue twister. Let's try maybe this point, 1, 1. That looks like an easy point to use. Now X is going to be 1 and Y is going to be 1. That doesn't want to draw very nicely. So let's try that. Y is 1. X is 1. 4 times 1 is 4. 4 minus 5 on the right hand side is -1. Is 1 less than or equal to -1? This is definitely false. So I'm going to shade on the opposite side of that line. Everything over here is going to be shaded. Next, I want to graph the one in blue, the inequality in blue. So the just less than portion tells me that I need to use a dashed line because points on the line itself will not be part of our solution. I also want to bring up that some of you will say, but where's my y-intercept? Remember, this is the same as if I had put a +0 on the end. So anytime you don't have a y-intercept showing, it's going to go through 0. So here we go. We're going to start at 0. My slope is 1. That tells me to go up 1, right 1. I'm going to extend my graph so that it can go all the way across in both directions. And our line is going to look something like that. Now I'm going to pick my test point. It needs to be a point not on the line, so maybe like a point, let's pick -4, -2. -4 is X, -2 is Y. Let's try that out. -2 is less than -4. +0 won't do anything for me. Is -2 less than -4? This is also false. So I want to graph on the opposite side of that line. Not this side where my point is, but over here. And now, because this is a system, I want to look for where the two shadings meet. The two shadings actually meet in this area, everything from here over. So all of this area is my solution. Really quickly, The two lines usually break my graph up into 4 different sections. Here is a little triangular section. There's a section over here, a section down here, and a section over here. The two lines, when they cross anyway, break my graph up into 4 kind of triangular sections. One of those 4 sections will always be my solution. So kind of keep that in mind as you go. One of the 4 should match your requirements. There is a possibility of having a no solution to a system of inequalities. So let's say that I had a line here and I had another line, let's say over here. If the lines are parallel, this is what could possibly happen. What if one line got shaded on this side and the other line got shaded over here? Where do the two shadings meet? Remember, in a solution, or for a system of inequalities anyway, we're looking for where the two shadings overlap. Well, when they don't overlap, there's no solution. So this is what a no solution could possibly look like in a system of inequalities. There is no such thing as an infinitely many solutions in inequalities, because in a system of inequalities, there's always an infinite number of points that will fit. They're already in our solution, so we can't ever just say infinitely many solutions, because that will always be true. So here's something to put in your notes. These are kind of the steps that you need to take to graph a system of inequalities. Graph the first inequality, shade the first inequality by picking a test point to find out where you shade. Graph the second inequality, then shade the second inequality. See where the two meet. Color the intersection, right? You're going to do everything in pencil until you get to the very, very end, and then you're going to use a colored pencil to color in the intersection portion of your graph, and that's your solution. Pause the video if you need more time to write this down. Otherwise, remember to write down any questions that you have, and take your online quiz, bring your notes to class, and I'll see you later. Have a great day.